Om Shri Sai Ram. Welcome to the 6th session of this chapter, Motion in a Straight Line. Having studied about motion, and also we have discussed about speed and velocity, and then we touched upon the relative velocity and the calculus part of kinematics, right? That is the mathematical tools which we employ to solve the physics problems, right? So, in this chapter, in this session, you will able to see the application of the calculus we have learnt. Alright. So, in this chapter basically we are studying about the average and instantaneous velocity as well as speed, but we will more emphasize on velocity. Alright. So, let us get started. So, average speed and velocity. What is average speed? Average speed is nothing but it is a measure of total distance covered in a given time. It is the total distance travelled or covered in a given time, and it is given by total path length by total time interval. So, in the second session itself we have studied about the speed, right? It is the path length by time interval, right? Average speed is nothing but it is a total path length and total time interval. Alright? Average velocity now. It is a measure of total displacement covered in a given time. How much an object is changing its position in a given time. Alright. So, it is given by average velocity is equal to total displacement by total time. Alright. To get more information about speed and velocity, go back to the second video and watch it to get the clarity. Alright. So, let us see this graph. What this graph says, as the time is increasing, the position is also increasing, right? The position is also changing. In which direction is changing? It is changing in the positive direction, right? The change in position is positive with respect to the t as it is going, as it is increasing, right? So, we can say this as the positive velocity or negative velocity. The moving, it is a object is moving here with the positive velocity, right? So, in other words, we can also say how can we calculate the velocity from position and time graph? Using slope, right? How the slope is here, how this straight line is changing, it is constant, right? Just take the angle, this is theta, and tan theta between 0 and 90 it is positive, the slope is positive. So, the velocity is positive. Alright. Now, second condition, second case. Now, here as the time is increasing, you can see how the position is changing. The position is changing in the negative direction. This is the positive direction of change in position, and as the time is increasing, you can see as the time is increasing, position is changing, but it is changing in the negative direction. In the other words, if you can see if you can draw a line, you can see the theta here. So, the theta here is what it is between 90 and 180. That means it is in the second quadrant. Our slope is what? Tan theta. Tan theta is negative in the second quadrant. So, here the object is moving with negative velocity. Otherwise, you can say that the final position, this is the initial position, the final position is lesser than the initial position, right? When the final position is less than the initial position, what happens? The change in position becomes negative. Then you can say that moving with the negative velocity, the object here is moving with the negative velocity. Alright, this is the second case. Now, see the third case here. As the time is increasing, is the object changing its position? The object is it going up or coming down? No, it is not changing its position. That means the object is at rest. So, these are the three cases for the position time graph, where we have studied about whether it is moving with positive velocity, here it is moving with negative velocity, there it is at rest. Alright. Now, let us see about the instantaneous speed and velocity. In here, you can see as the time is increasing, how the position is changing. The slope here is constant. The slope here at every point is theta. Let it be theta 1, let it be theta 2. So it also will be theta 2. Some constant slope, right? The slope is not changing at any point. If you take at any point, the slope, the rate at which the position is changing with respect to time is the same, whether it is negative or positive, but the change is same, right? When the change is same, what we can call as, it is under uniform motion, right? It is under, the velocity is not changing, right? It is moving in the uniform velocity. It is covering equal displacement or equal distance in the equal intervals of time, right? Why I am saying this? Because instantaneous speed and velocity, where it becomes significant, when your motion is non-uniform. All right, when your motion is non-uniform, that means the particle, the object is changing its displacement or changing its position. The change in position is unequal when you see it in the equal intervals of time. It is covering unequal distance in the equal intervals of time. So that means it is in the non-uniform motion. If I want to calculate the speed at some point, what happens? I cannot have the appropriate answer, because it is either increasing or decreasing. If it is constant, then I can calculate the average velocity, but it is changing. Some information is being lost. For example, from 1 second to 3 seconds, it may increase up to 2 seconds and decrease from 2 to 3 seconds, right? If I ask from 1 to 3 seconds, what happens? You will see the initial value, you will see the final value, and you will give me the average velocity. But is that happening? Is it average all the time along from 1 to 3 seconds? No. From 1 to 2 it is increasing, from 2 to 3 it was decreasing, right? So such kind of information, if you want to calculate, you need to use instantaneous speed and instantaneous velocity, right? At that particular moment, if you want to calculate, if you want to use these two. Let us see the definitions. What is instantaneous speed? The measure of distance covered at that particular instant of time. It is not the interval. In average velocity is the time interval between. It is total path length by total time interval. But here instantaneous speed tells you that measure of distance covered at that particular instant of time. At that instant of time, not the interval. It is not between 1 and 3. If you want instantaneous velocity at 2 seconds, you will get that. Alright. In the same way, instantaneous velocity. What is instantaneous velocity? Measure of displacement covered at that particular instant of time. How much the particle, how much the object has displaced at that particular instant of time. The rate of displacement at that particular instant of time. So that is very useful for us. Alright. Now let us see by definition. By definition we have already saw. Let us see by derivation. So let delta x be the distance travelled in the time interval between t to delta t. There is a time interval. If a particle has started at t, and as the time increases from t to t plus delta t. Alright. So this is the corresponding change in what distance. The initial time is t, final time is t plus delta t. What is the change in time interval here? Delta t, right? T plus delta t minus t, that gives you delta t. So delta x distance travelled when t is changing from t to t plus delta t, small increment in time. So the average speed is given by, so if I give you the average speed, if I want the average speed, what it will be? It will be in this time interval. In this time interval, how much distance it has travelled, the ratio of these two, right? If you plot the graph between x and t, what happens? The slope will give you the average speed. here. So here if I want the average speed, I need to time interval between this much distance a object is traveling. So the average speed will give you delta x by delta t, right? Now here the instantaneous speed starts coming. How? Now as the delta t approaches to 0, the distance delta x also approaches to 0, but the ratio delta x by delta t has a finite limit. In the fourth session, when we talked about the differentiation, we have studied so in detail about this, right? If the position is a function of time here, there the y is the function of x. Here as you are plotting between, what is this? This is distance, okay, distance, let it be x, and this is t, okay. Now distance is the function of time, that means as the time is increasing, distance is also changing. So here he gave that delta x is increased for the increment of time. How much increment? Delta t. If you increase the t value by delta t, for example, if the curve is like this, okay, it is non-uniform, the velocity is non-uniform because it is a curve, it is not a straight line. At every point the slope is changing. So if at one point if I want the instantaneous speed, what I have to do? I have to, for example, this is some value t, it started at value t. For suppose I am concerned between t and delta t, right? So it passed through by delta t time. So what is the final here? If this gap is delta t, what is the final time here? It is t plus delta t. So in this time it has increased some distance, corresponding distance. So corresponding distance at t is some x. At t plus delta t, it will be what? X plus delta x, if this distance is delta x, okay. Now as I shrink this time interval, that means this time delta t which is increased is approaching 0. When it approaches 0, delta x also comes to 0, tends to 0, but this ratio delta x by delta t will have a finite limit. It approaches to some value, depends on the function how it is changing. It approaches to some value, that value we call it as instantaneous speed as delta t is tending to 0. Alright, as when the delta t is tending to 0, that means there is no time interval there at that instant point of time, okay. At that instant point of time where the value is approaching, that we call as delta instantaneous speed, alright. So see here, as the delta t is approaching 0, that means it is shrinking to delta p, there is no 2 points over there, it is approaching to 1 point. When it is approaching to 1 point, that means I am having the instantaneous speed at that particular point, alright. Now as we saw about instantaneous speed, it is instantaneous velocity also similar to this. Let us see instantaneous velocity. Let delta r is the displacement in the time interval delta t. So here as there was delta x in the time interval delta t, here as it is a vector, it has a direction. So r is a position vector, delta r is the change in the position vector in the delta t time. As the time is increased by delta t, this much displacement it made. So average velocity will be, average velocity you already know, net displacement, net change in position by total time taken. Now we want to know instantaneous velocity. To have instantaneous velocity, what it should do? The delta t should tend to 0, right? As delta t approaches 0, the displacement delta r also approaches 0, but their limit will be the instantaneous velocity v of the particle at time t is delta t tends to 0. So this approaches 0, this becomes dr by dt. So this notation we have already studied in the calculus part of this session, of this chapter, in the fourth session I guess. So you can go back and see how delta r and delta t is denoted as dr and dt, because as delta t tends to 0, it is very small, these two are shrinking to one value. So this we denote as dr by dt, how r is changing with respect to t, right. So this is about the instantaneous velocity and instantaneous speed. In instantaneous velocity, displacement is the function of time. In instantaneous speed, what happens? Distance is the function of time. All right. Where the instantaneous velocity and instantaneous speed are more significant? It is more significant in the non-uniform motion. In the uniform motion, you can think that instantaneous speed and average speed are same, because the slope is same overall. This limit and everything comes when you have a different slope. When the slope is changing, when the rate of slope is changing, that means you have a non-uniform motion. Okay. So let us go and see how the average velocity is different from the instantaneous velocity. How it is different? What does the average velocity gives you? See, the average velocity does not give any details of the motion of the particle, it gives only the result of the motion. Motion is completed, you know that it started at time it completed the journey at some time interval 4 seconds or 5 seconds, okay, and you know it has covered some distance. So you just take the ratio of the distance covered by the time interval, or change in position by the, as we are talking about the average velocity, it is the change in position by the time taken to change that position, that we call as average velocity. But there is much more information in between the interval. It may increase the velocity, it may decrease in the interval, but we don't know that, because we are only concerned about the initial value and the final value. So instantaneous velocity will give you that information as well. Instantaneous velocity defines how fast the particle moves at a particular instant of time. Here it gives you the result of the motion. After the motion, yes, it has moved with some velocity in the given time. But here instantaneous velocity will define you how fast it is moving at a given particular instant of time. So this is very significant. All right. Now let us solve an example. You have a graph. See how the position of an object is changing with respect to time. See, the position time graph for a motion of an object for 20 seconds is shown in the figure. What distances and with what speeds does it travel in the time intervals? He has given 4 questions. In 0 seconds to 5 seconds, we need to calculate what distance has it travelled, with what speed does it travel. So we have 0 to 5, 5 to 10, 10 to 15 and 15 to 17.5. What is 0? 0 to 5, this. 5 to 10 from here to here, 10 to 15 from here to here, from again 15 to 17.5, this interval. So these all intervals we need to find how much distance it has travelled and also how much, with what speed it has travelled. Alright, it is position. From the position time graph we can find the speed also, right, but from the distance time graph you cannot find the velocity. All right. So calculate the average speed for the total journey, and at last we need to find the average speed for the total journey. Now let us see. This is the thing. So during, first question, during 0 to 5 seconds you can see up to 2.5 seconds where the particle is at rest. It is not moving. Is there any change in position up from here to here? The particle is at rest. It is not moving anywhere, right? It started from 0.5. It started its journey from 2.5 seconds, right? From 2.5 seconds it started journey, and what is the change in position at 5? 4. So from 0 it went to 4 in the 5 seconds. So let us see the working. So during 0.0 seconds to 5 seconds, distance travelled is 4 meters, and speed is distance by time, you already know, in this interval. So distance is 4 meters And what is the time taken? 5 to, because he has asked, specifically asked from 0 to 5 seconds. Had he asked how much time it took from the beginning of its journey, how much speed from its beginning of its journey started from 0 to 2.5, right? Then we could have used 2.5, but he specifically asked us from 0 seconds. So our total time taken will be 5 seconds in denominator, and that is 4 meters is distance. So when we divide we get 0.8 meter per second. All right. Now from 5 seconds to 10 seconds. So this is the thing, from 5 seconds to 10 seconds, it started from 4. The initial position was 4, and at 10 it reached 12. So what is the total distance travelled here? 12 minus 4, that means 8 meters it travelled. How much time it took? 5 seconds it took. So divide them, you will get 1.6 meter per second. From 10 to 15 seconds, the same, you can see from 10 to 15 seconds, is the particle changing its position? Is it going up or coming down? Because this is position. To change any position, it should either go up or come down, right? But as the time is progressing from 10 seconds to 15 seconds, it is at the same position at 12 meters itself from the origin. So it is not changing any position. So what we can write? It is not traveling anywhere, it is staying there. So the distance travelled is, if this is the initial and this is the final, it is the same, 12 minus 12. Here also it is 12, there also it is 12. So 12 minus 12, that gives you 0. So 0 by anything gives you 0. That means here the speed is 0, because it is not traveling. If you travel, then you have a speed. If you don't travel, how can you have a speed, right? 12 to 0. That means it is reversing its direction. Previously it went from 0 to 12 and it turns back from again to original position. But they asked about the speeds, not the velocity, right? Speeds is the distance travelled. So this is the distance it travelled. So how much distance it travelled? It travelled how much? 0. This is 12. That means 0 minus 12 minus 12. If it is velocity, it is what? 0 minus 12 gives you minus 12, and speed is given by distance by time, and here 12 by 2.5, that gives you 4.8. It is not minus 4.8. If it is velocity, it is minus 4.8. all right. Pause. So in this journey, you can see from 15 seconds to 17.5 seconds, it is decreasing its position, right? It is changing in position in the opposite way. From the 12 it is coming to its original position, which is 0. So the change in position is what? Distance travelled is, here 0 minus 12 meters we have written in terms of position. Position is changed by minus 12, but the distance travelled is 12 meters. It is mod. Okay, distance travelled is 12 meters. Now, what is the speed? Distance by time. What is the distance travelled? 12 meters. How much time it took? From 15 to 17.5. The time interval is 2.5. So 17.5 minus 15, it is 2.5. That is equal to 4.8 meter per second. Now, if I ask you what is the average speed, what is the average speed between this time interval? Easily you can say, what is the change in position? The change in position is velocity. Average is, the change in position is what? Minus 12 by 2.5. That gives you minus 4.8 meter per second. As the slope is constant, it is a straight line, slope is constant at everywhere. You can see this is theta, theta, the same theta 2, theta 2. So to everywhere here the average velocity is instantaneous velocity everywhere. Here also the average velocity is instantaneous velocity here. All right. So this is the one of the example where we can solve for, if the graph is given, using the details on the graph we can solve for average speed and average velocity in the last sum we have seen. So now if we talk about the overall change in overall speed, that means it started at 2.5, ended at 17.5. In this duration of time, you know the speed is positive here, the speed is, velocity is positive here, velocity is negative here. Alright, there is a some speed in this here, because in this interval of time it has covered 12 meters. If you talk about speed in this interval of time is 10 minus 2.5 gives you 7.5 seconds. In first 7.5 seconds, if you calculate from here, from the beginning of the journey, what happens in the 7.5 seconds it traveled how much? 12 meters. But at last you can see in 2.5 seconds it traveled 12 meters, right? That means here the speed is more, here the speed is less compared to in the last phase of the journey, right? You need to average out. When you want to average out, what do you have to do? You need to take the total distance it traveled by the total journey's time. Total distance traveled is what? 12 meters here and 12 meters in the opposite direction. We are talking about the distance, not the displacement. So total distance 12 meters and 12 meters, that gives you 24 meters. Total time elapsed of the journey, it started at 2.5, ended at 17.5. Total duration of journey is 17.5 minus 2.5, that gives you 15 seconds. So average speed is total distance by total time, total distance you have got, total time you have got. So that gives you 1.6 meter per second. So now what is average velocity for the total journey? It is 0, because it is coming back to its original position, right? It started at 0 and ended at 0. See, the position, the y value on x-axis is always 0, right? So it is started at 0 and came back to its original initial position. So what we can say, the average velocity of this graph is 0, the average speed is 1.6 meter per second. So like this we will solve 3 more examples and get accustomed to it. All right, we have an example, a problem. So let us solve this. What is given in the problem? The position of a particle is given by, as x is a function of time, the position is changing with respect to time, that is x is function of time. This is, as we wrote, y is function of x, like x is a function of time. That is equal to how it is changing, how the position is changing with respect to time. The function is given as t3t plus 0.5 t cube. All right, it is 0.5 t cube. So this is the function given. Calculate the instantaneous velocity at t is equal to 2 seconds. So at t equal to 2 seconds, at that particular point, what is the velocity of this given particle? So this is the position given to us. So we need velocity. So just differentiate. If you differentiate with respect to time, what happens? Dx by dt will give you what? Velocity. And when you get the equation of dx by dt, derivative of this, it will be in terms of t. Just plug in the terms of t, just plug in the t at that point of time, then you will get the instantaneous velocity. Let us solve along. So x is given by that. So dx by dt will give you what? Dx by dt is what? D by dt of, what is the function given? 3t minus plus 0.5 t cube. All right. So what this derivative will give you? It is 3 plus 3t will give you what? The derivative of 3t will be 3. with respect to t here. So, it will be what 3 into 1.5, 3 into 0.5, it will become 1.5, that means 1.5 t square, that is your dx by dt. Now, what he told, he asked us the instantaneous velocity at 2 seconds. So, after it traveled 2 seconds, at the point of covering 2 seconds, what is the instantaneous velocity at that particular time? So, just plug in two value here. So, at t equal to 2 seconds, v instantaneous will be equal to 3 plus 1.5 into 2 square, because t equal to 2, plug in the value. So, what it becomes, that is equal to 3 plus 6, that gives you 9 meter per second. So, this is your instantaneous velocity at t equal to 2 seconds. Alright. So, first what you have to do, you have to take the derivative with respect to time, because it is position. It is position. Now, we need to take the derivative with respect to time. So, we know the basic differential formulae. So, how do we find the derivative of 3t with respect to t? Like we have studied, d by dx of 5x is what, 5. In the same way, d by dx of 3t is 3, because here it is 1 into t to the power of 1 minus 1, that gives you 3. Here also 3 comes here. So, 3 into 0.5, 1.5. What is left? 3 t power 3 minus 1. So, it becomes t square. So, once you find out the dx by dt, it is nothing but the velocity, right? Velocity at, if you want to instantaneous velocity at 2 seconds, then you will get this 9 meter per second. And he also asked us the average velocity between 1 second and 3 seconds. So, if you want to note it down. So, what is the average velocity? What is the formula for average velocity? What do you mean by average velocity? It is a net displacement by total time taken. How much time taken from 1 second to 3 seconds? Initial time final time minus initial time, 3 minus 1, the total time taken is 2. What is the displacement at 3 seconds and what is the displacement at 1 second? That we need to calculate. Put that 3 here, some displacement will come. Put 1 again here, that displacement will come. Final displacement minus initial displacement, calculate that, and by total time. So, I hope you have already wrote this, and I am wiping this out. Alright. So, now average velocity calculation. Average velocity. Now, to calculate average velocity, we need to calculate what? We need to calculate the distance travelled at 3 seconds and 1 seconds. So, x at 1 second is what? Put 1 there. So, it gives you 3 into 1 plus 0.5 t cube 1 cube, that is nothing but 3.5 meters. All right. Now, at x equal to 3, what it will be? 3 into 3 plus 0.5 into 3 cube, that equal to 9 plus 3 cube is 27, 27 by 2 will be 14.5. 14.5 meters. So 14.5 plus 9 will give you how much? 23.5 meters. So displacement at x at t equal to 1 is 3.5 meters. Displacement when t is 3 seconds is 23.5 meters. So how much it travelled? Total displacement. Total displacement. Final position minus initial position. Final position is what? 23.5, right? Let this be x final, let it be x initial. X initial. Okay. So it will be 23.5 minus 3.5. How much? 23.5 minus 3.5, it will give you 20 meters. So the net displacement is 20 meters, and how much is the total time taken? 3 minus 1 is 2. So V average is 20 meters by total time taken 3 minus 1, final time minus initial time, that will give you how much? That will give you 20 by 2, 10 meters per second. This is seconds. So the average velocity between this time is 10 meter per second. How much we got instantaneous velocity? Instantaneous velocity at t equal to 2, that is 9 meter per second. So these are the two cases where he asked us to calculate instantaneous and average velocity between this time interval. All right. So let us go to the next problem. Here also we were given that x is changing as t is changing. So he asked instantaneous velocity at t equal to 0.25 seconds, t equal to 0.5 seconds and t equal to 1 second. All right. So to calculate the instantaneous velocity, first what we need to do, we need to calculate the derivative with respect to x. So dx by dt will give you velocity, right? So dx by dt is what? Just I will write it down to make the thing simpler. D by dx of minus 3t square. All right. So it will be d by dt of 3t will be what? 3 minus d by dt of minus 3t square will be minus 3 into 2 into t to the power of 2 minus 1. So that will be equal to 3. So that will be equal to 3 minus 6. 3 minus 6t. All right. So as the time is changing, this is how the velocity will change. Now he is asking the instantaneous velocity at 0.25. So put 0.25 here. So V at 0.25 is what? 3 minus 6 into 0.25 is nothing but 1 by 4, 6 by 4. So what it gives you? 3 minus this is 3, 3 is a 3, 2 is a, it is 1.5, 3 minus 1.5 is 1.5. So, it is 1.5 meter per second. Now, V at 0.5, say instantaneous velocity at 0.5 seconds is 3 minus what is given 6 into 0.5 means 1 by 2. So, 1 is 3 is. So, it gives 0 meter per second. Now, V at 1 second. So, that gives you what? That gives you 3 minus, what is the equation? 3 minus 60, right, into 1. That gives you 3 minus 6, that is equal to minus 3 meter per second. See, as it is changing its position, at 0.25 it has the positive velocity, at 0.25 seconds it is having the positive velocity, at 0.5 seconds it came to what? Rest. That means there is no change in position, and at 1 second it is having negative velocity. That means you can think of that it is going, it is decreasing 1.5, it is decreasing to 0 at this point and further decreased in the negative direction. That means a particle is coming in a reverse direction. Okay. At some, for example, if you take a graph, here from x it is increasing. If you put 0 here, what happens? At t equal to 0, x will be also 0, right? Here, this is t, this is x. At 0.25, what at 0.25 what happens? It has some value. Okay. Now, after that what happens? At 0.5 seconds what happens? It is further increased. This is 0.25. For example, this is 0.5. It further increased. Okay. If you increase, you can know. You just plug in the value of 0.5. That means 3 by 2 minus 3 by 4 it becomes. So, some further 0.75 something it comes. So, it increases further. At when t equal to 1, you see here again it comes back to, at t equal to 1 it comes back here. This is 0.5, this is 1. So, it is increasing as the time is moving. From 0.25 it is at this point, 0.5 at this point, at 1 second it is coming back. Just plug in the value of 1, you will get 0. 3 into 1 is 3, 3 minus 3 is 0. So, you may be wondering, here the change in displacement is 0 from 0 to, if there is a 0 and this is 1 second. So, change in displacement is 0, but here at instantaneous velocity at v is equal to 1 second will give you minus 3 meter per second. Why it is, why there is discrepancy? Because here we are taking the average interval of 0 to 1, but here it is taking only the value at 1. When you take the interval of 0 to 1, you will get the value as 0, average velocity as 0, but we are calculating the instantaneous velocity. Alright. So, at v equal to 0, at time t equal to 0, what will be the velocity? Or at time t equal to 0, what will be the velocity? It starts at 3 meter per second. As the time is increasing, you can see at t equal to 1, it becomes minus 3. So, at 3 equal to 0, it starts with, so at 3 equal to 0, it is at here 3 meter per second. As the time is going, what happens? For example, at t equal to 0.5, you substitute. At t equal to 0.5, what is the velocity of the particle? T by 2. T by 2 means 1 by 2. 1 by 2 gives 6 into 1 by 2. It is 3. 3 minus 3 will give you 0. So it boils down to 0 here at 0.5 seconds. When you put 1, what happens? You put 1 here, 3 minus 6, it gives you minus 3. So if this is minus 3 here, if this is 1, so see how the velocity is decreasing. This is the position time velocity, this is the velocity time velocity from this graph. Alright, so this is the basic structure how you need to think when you are given the position time graph. First we have calculated the instantaneous velocity at this particular period of time, at this particular instant of time, and then we just saw how the particle is moving in a graph. From this graph we have plotted velocity time graph. Alright. So the last problem of this today's session, let us see, very interesting problem. See, here the particle is changing its position with respect to time in this manner. So at what time velocity of the particle is 0? He is asking. So to calculate that, let us first find the slope to calculate the velocity. If you how can you find the velocity? Dx by dt again. That what he told, at what time velocity of the particle is 0. So make that equation equal to 0, you will get some roots of t. So that roots will be equal to the time at which the velocity of the particle is 0, right. So let us calculate. So the velocity is given by v is equal to dx by dt, that is equal to d by dt of 3t cube plus 5t. Okay. So differentiate it, what happens? It becomes 9t square plus 5. Now he is asking at what time velocity of the particle is 0. So this is the velocity equation, velocity is changing with respect to time, right. So this is v of t, velocity changing with respect to time, velocity is function of time. Now he is asking at what time the velocity is 0. First let us make the velocity is equal to 0. So 9t square plus 5, let us make it to 0. T square is equal to minus 5 by 9. The time is coming in the negative terms, right? Is it reasonable? Just you think of it, can the velocity be negative or 0? If you put the time t equal to 0, that is where the particle is starting, the minimum time is 0. Okay, just put the value 0 here. When you see, you put the value 0, it gives you what? 9 into 0 square, that gives you at t equal to 0, what is the velocity? V is equal to 9 into 0 square plus 5. That means at t equal to 0, it is already having the velocity. How much velocity it is having? 5 meter per second velocity it is already having at 0 time 0. When we started calculating the time, the motion of the particle, it is already having the velocity of 5 meter per second. Now he is asking at what time velocity of the particle is 0. Now you can see, is this the function decreasing or increasing? As the time is increasing, the function is increasing. It is not coming down. The position is increasing, right? If you have any minus signs here, you can say that the function may decrease, and then you will have some roots. You can see here the function is increasing. The function is increasing means what happens? From 5 meter per second, it is only keeping on increasing. The velocity is only keeping on increasing. At no time it will have the velocity of a particle 0. So the answer will be, there will be no time where the velocity of the particle is 0, right? Because you are getting imaginary roots. Imaginary root is not reasonable. So Here at time t equal to 0 we have calculated this is the minimum velocity it can have, from there it keeps on increasing. Alright, I guess you got the flavor of instantaneous velocity and average velocity, and I hope you have studied well about the integral calculus and differential calculus. That will be further useful in the coming sessions. In the next class we will be studying about the acceleration. What is acceleration? Is nothing but the change of velocity. Now until now we have informally discussed about the non-uniform motion. There we will discuss about uniform velocity, where something is going with the same velocity. There what happens, there is no change of velocity. When there is non-uniform motion, there will be change in velocity. When there is a change in velocity, there is acceleration. So that we will discuss in depth, and also we will see the velocity time graphs, and also some more interesting problems we will solve. Alright, till then, thank you. Sai Ram.